Hello and welcome to the OLM Working Group. Today is Thursday, April 7th. Today on the agenda, we are discussing the integration between RuckPack and DEPI, or a DEPI-like component. And we're talking about basically a new component that we're looking to potentially introduce to help with some of the use cases around RuckPack and the new APIs. So I've put together a quick document outlining this component and potentially what it would look like. And it's called the pivoter. And so I'd like to present the pivoter and have it be completely open for discussion. If anyone has any questions at any point or comments, feel free to post in the chat or just reach out directly. But hopefully this material is understandable and it's useful. So let's get started. Let's start looking at what is this pivoter. So the pivoter, this new component that we're envisioning, is a component that sits on top of RuckPack and is responsible for making pivoting decisions between installed content on the cluster and content available in catalogs. The pivoter makes use of the bundle and bundle instance APIs to stamp out content based on what is available in a provided catalog source, ensuring that the latest version of a particular bundle instance is installed on cluster. So why is it called a pivoter? Pivoting in this context specifically refers to updating the bundle name field on the specified bundle instance to the name of a different bundle to trigger RuckPack to delete the resources associated with the old bundle and create resources associated with the new bundle. So right now in RuckPack, if you want to say, switch versions of a particularly installed bundle instance, you have to manually edit the bundle name field. And so it's sort of a manual upgrade process. So what the pivoter is, in its essence, is trying to do is it's trying to automate that process. And the process exists in OLM today currently, right? With this subscription mechanism, we have a way to go between one version of an installable, like an operator, to the next version, based on what's in the catalog. So the pivoter is sort of duplicating that functionality, but is duplicating it in the space of the new APIs and the sort of V2 realm. So that's in essence what the pivoter is trying to do. Here is there's a picture that I put together that shows sort of the interaction between the pivoter, RuckPack, and a catalog source. So the pivoter resolves catalog source, which is updating by itself or through some external mechanism, like a user updating it. And then it pivots the underlying RuckPack resources such that you can always be sure that you have the latest version of content installed on the cluster based on what's in the particular catalog. So before we continue, does anybody have any questions or comments about what's being said so far? If not, let's continue. So there is some overlap between the pivoter and DEPI. DEPI is a component that lives on and off cluster and can perform arbitrary resolution over catalogs. So the state of DEPI is something we can definitely talk about further, but DEPI, from what I understand, is meant to perform resolution on registry v1 bundles, which is the current bundle format that OLM supports, the only bundle format that OLM supports, and is not, the registry v1 bundle format is not really supported in RuckPack currently. RuckPack supports plain v0 bundles, which are essentially bundles with a series of static YAML manifests in them, and there's no CSV, there's no concept of a CSV. So since DEPI is like conceptually similar to what I'm calling the pivoter here, it's not exactly the same thing. So my goal with this conversation is to not necessarily get focused on what DEPI is or the state of DEPI, but to think only about this pivoting problem and basically calling it the pivoter, which is sort of an arbitrary name. But there is definitely some overlap, and it's notable to think about where the lines between the pivoter and DEPI really are. So here are some use cases for the pivoter as I described it. It can keep a bundle instance up to date with content available in the catalog for that particular bundle. So that's basically the key use case. It's ensuring that you can move between different versions of a bundle for a given bundle instance automatically, and not have to manually update the given bundle instance with whatever content's available in the catalog. It's not even necessarily clear what the content in the catalog is on the cluster. So you expect that there is some kind of a process that can do the pivoting for you. Furthermore, the pivoter, it should provide an API that acts as an entry point for users interacting with RuckPack. This is similar to the subscription API in OLM today. It won't be exactly the same thing, but there basically needs to be some mechanism to declare the intent of I want to keep this particular, a package, this particular content up to date at all times based on what's in the catalog. And so the API for this is sort of murky. It should be an API that the pivoter understands, though. This is sort of declaring intent to the pivoter. It may be simple to the input API. So the input API is something that's discussed in the strawman. And we could take a quick look at how that looks like. It might be beneficial. But sort of the input API looks like this. It's in the DEPI group version, but it has basically a set of constraints on it. So you can pass it things like name, namespace, package, channel, and then it can basically ensure that for this particular package coming out of this catalog, that the resolution will be performed against that catalog, and you will have an up-to-date version of that package on your cluster at all times. So this is what I'm potentially envisioning as the entry point to this pivoter is essentially an input. So now we can look at what are the components of this pivoter. Tyler, would you like to speak to the components in the pivoter?
Yeah, sure. So basically, there's going to be two things that we're going to need to add for this this MVP implementation. First thing we're going to need to add is a controller that can reconcile this input API that we're potentially going to be adding. It's going to exist, as we mentioned, kind of between the existing catalog source APIs as well as the RuckPack APIs. And on top of that, it should be able to resolve in a similar manner that core OLM already does. So whether that's using the actual resolver that core OLM uses now, and maybe breaking out the resolver into its own package and then importing it and adding some maybe RuckPack specific features to there so that we're able to actually resolve. Or it might be that we just kind of start from scratch and build something that's really hyper specific to RuckPack. So from an MVP perspective, we have some things that we really want to make sure that we're hitting, which make it a bit easier on us to begin with, in the sense that it's not going to be super generic to start. That's not the main focus. The main focus is making it really specific to tailor to a couple of features that we want to get implemented. Namely, in this sense, we want to be able to look at one specific channel on in one specific catalog as well. So we don't need to worry about multiple catalogs to start out with. We don't need to worry about multiple channels to start out with. In that channel and in that catalog, we want to be able to pivot across bundles and ultimately produce bundle instances that get updated. So that is that. And then I think we have some open questions here. Any questions on what we've said so far?
I have one, maybe a comment / question, which sure. Is part of what the straw man also talks about, I think, is this concept of a resolve set bundle, which in my mind is basically just like a list of bundles and bundle instances effectively, such that like it's almost like another plain manifest bundle whose contents is just more bundles and bundle instances. It's like a composite bundle where the idea is that like we can abstract the resolution logic from the actual let's go and touch the bundles and bundle instance logic with like an extra layer in between. So I wonder if you guys thought about that piece of the strawman architecture as part of this or not.
So we did think about it. It definitely adds another layer of complexity. And this sort of like wrapper around bundles and bundle instances and the new sort of bundle type. I definitely think it's worth exploring more, and whether that like additional complexity is worth it, is beneficial.
Yeah, I think the use case that comes to mind for me for why you might want an abstraction like that is that you can decouple the source of the catalog information from the component that actually performs the pivoting, right? So you could imagine that with these new APIs, like we've got a whole bunch of content for registry v1 bundles that are in the existing catalog sources. So let's build this. I guess I'll call it like resolver, right? Like something that knows how to talk to a catalog source and produce a resolve set bundle. But maybe in the future, what we really want is maybe like a totally different API for connecting to catalog metadata. Maybe we want, and I think we've talked about this even a little bit in the open questions, maybe we want it to be HTTP. Maybe we want a cluster scoped catalog source. Maybe we want the format to be different, whether it's file-based catalog directly or some translation of that. So I guess like it might be nice to build that abstraction layer such that it's really easy to swap out those things, but still have all of the underlying componentry still kind of work off this resolve set bundle concept. The other nice thing, of course, too, is that if you build this layer in between, then like the thing that the resolver has to be concerned about is, am I capable of producing a resolve set bundle from the source that I know about, like yes or no? And then it's up to this other component that knows how to read a resolve set bundle and make it so on the cluster. And so like you start getting smaller components that do one thing and do it well, rather than one larger component that has to do a bunch of things well together. I guess it's kind of like a microservices architecture thing.
Right. Yeah, no, so it totally makes sense. So this resolve set bundle, essentially that API would also be something that's part of RuckPack. Is that fair to say? Like the RuckPack would be able to like disassemble the resolve set bundle into a series of bundles and bundle instances?
Yeah, like I think it would be very similar to the plain bundle, except we might need a different provisioner that knows how to go and grab a resolve set bundle from somewhere in the cluster. Or maybe we would need a new bundle type that is able to source bundle content from a CRD or like from some API somewhere rather than from Git or an image. Right, like you could imagine if there was a way to source a bundle from a persistent volume or from a config map or something, or a series of config maps, then you could have this resolve set bundle provisioner know how to read that and produce kind of the same exact behavior that the plain provisioner does. And you could even reuse that potentially.
Okay, yeah, it's super interesting. Definitely something that's worth thinking about. I will add this to the write-up. So maybe if we add some newer APIs, we can make this component basically smaller and decouple it more from sort of the RuckPack APIs themselves, which sounds like a big win. I see that Kevin, you have you posted in the chat about basically catalogs. This is this is another big open question around this pivoter implementation of essentially how does it look like to integrate with the existing catalog source API in the Rockpack world? Are we able to do, go ahead, sorry.
Well, so all I was just saying is that like the concept of like global versus namespace catalog sources is a convention of the APIs that interact with it and not the catalog source API itself, right? Like whether we talk about a cluster catalog source API or we just say that like the catalog source API is only useful in the same namespace as like wherever you are running Ruckpack. I think that's relatively separate from the question of like, how does Ruckpack, or maybe there's just any catalog source in any namespace Ruckpack can just read. All I was saying is that like where content applies onto the cluster probably just doesn't make a lot of sense for us to really even think about kind of like how the install plan API works today in this context. So like, I don't know. I mean, maybe a cluster catalog source API makes the most sense. Maybe we still want to namespace it, but I don't know that we necessarily need a new catalog source API right away to still do just something totally different. Because I think it probably just has to happen either way.
So Kevin, my question I think there would be, if we have a namespace scoped catalog source API like we do, does that mean that Ruckpack would have access to all of those anywhere all the time? Or would we just ignore all but one of them?
I'm saying we can probably pick one of those options, but my point is just that like, even if you install OLM right now and then use the catalog source API as is, you're not going to get like, it's not like there are any code changes that have to happen in OLM for you to just make a new choice there, right? Like either way, you're going to have like, once you start that catalog source up, you're going to have to point to the endpoint that gets exposed in Depi or Ruckpack or wherever we're going to put at least the first iteration of pulling content from the catalog. So like that thing is going to have its own definition or context of how it interacts with catalogs and in what scope.
I don't know if I totally follow, but I'll buy it for now.
Like what I'm saying is that the fact that there's like one special namespace where you drop catalogs into that namespace, and then that content can be read across the whole cluster. That's just because when the install plan API or the subscription API is generating stuff, it happens to know about that convention because that's where that is encoded, not because of anything to do with the catalog source API itself. So anything we do with Ruckpack is net new anyway.
Yeah, so I guess like from the perspective of I'm a cluster admin and I want to try to make use of these APIs in a way that's intuitive. That's where I'm coming from in terms of like, what would be the intuitive conclusion of a cluster admin that uses a namespace scoped cluster catalog source API in a world where operators are installed kind of globally with cluster scoped APIs?
Yeah, that's fair. And maybe to start, we just say that the catalog source that interacts with Ruckpack needs to be in the same namespace as the Ruckpack, the provisioner that you install, or the thing that talks to the catalog source, whatever that input API interacts with, or like wherever that controller lives, it needs to be in the same namespace just to start. I do think you're probably right that like eventually we probably want a cluster catalog source API, and maybe that thing looks like something else, but I don't know if we need to necessarily build that right away as part of an MVP.
I see. Yeah, I agree.
Yeah, that's fair. And that's kind of why I have some questions here on using the existing catalog source API. Essentially, part of this problem is, and folks that are more familiar with the file-based catalog work would know, can catalogs have bundles with different schemas in them? What does it mean for a file-based catalog to be built with plain v0 bundles today? What does that look like?
Yeah, so I mean, theoretically, as long as there's nothing new that needs to go into file-based catalogs to like know how to be able to generate a bundle spec, then file-based catalogs don't have to change. The thing that I think is more interesting is, and I was literally just typing this up in the chat, but since we're talking about it, if you all of a sudden have a catalog source on the cluster that is backed by a catalog that references plain v0 bundles, how do we tell OLM to ignore that, right? Like, it almost seems like we need to have like a provisioner class sort of concept for catalog sources to say, hey, this catalog source goes with OLM, this other catalog source goes with RuckPack. Or is there a way to do some negotiation within the contents of the catalog source that you know, the resolver can detect, oh, this is a registry v1 bundle, so I'll recognize this is something I can manage with OLM. And the RuckPack thing could also do the similar thing, but in reverse, right? Where it says like, oh, I don't know about this bundle format, so I'm gonna either fail or ignore that or something.
Yeah, no, that's an interesting point around essentially having the question of having them coexist, RuckPack and OLM potentially together.
Right. Yeah, which
different-
like one way to solve that is you just don't share any APIs at all, right? But if we do want to share APIs, then I think we have to answer that question.
Yeah, so different gRPC endpoint Kevin's proposing. That's certainly like I think a fair compromise. Same API but different endpoint. There is so this component which I guess we're calling the pivoter in this context, it would also have to be able to understand the gRPC API that the catalog source is exposed, right? And be able to negotiate that. We've seen I don't know, some strange behavior on the gRPC API in catalogs. But maybe it's just in the specific context of our EDE suite. Would it make a big difference if the API that was being exposed for catalogs of v1 of plain v0 bundles to be HTTP based? Is there in the same pod, or is that's nonsensical to have gRPC and HTTP coming out of the same pod?
So I think part of the problem there is that the catalog source API like tells you how to connect to the actual pod to like do the gRPC connection. So there's not really, unless we're going to go and add something to that API to say like, or here's how you connect to HTTP, there's not a real easy way of doing that. In my mind, like I think the gRPC API, at least list bundles, is enough to get started, and we could just use that. In the long run, I think it's probably interesting to separately think about, can we just serve the file-based catalog like as a tar, and then have the resolver know how to unpack and read and do content negotiation that way, which I think could help. Like right now, we've basically got like two interfaces. There's the file-based catalog or the SQLite database. That has to be translated into the gRPC interface for the clients on the cluster to read. So it'd be nice if we could eliminate one of those interfaces such that if something needs to change, we don't have to change it in both places.
Okay. Yeah, no, that's fair.
Yeah, so like the example that we're talking about right now is wanting to add arbitrary properties to channels and packages, and how do we pass that down to consumers that are looking at that API? And right now, like there's nothing really in the gRPC API that can do that in the way that makes sense. So what we basically have to do is say like, okay, well, let's go and change, our SQLite / file-based catalog API to support holding those properties, update the thing that update the gRPC server to send them. And to send them, we also need to update the gRPC, proto files to allow us to put those properties in a field somewhere. Oh, but also like the list bundles thing doesn't really quite handle, listing channels and packages. So it ends up snowballing, right? So I think we need to think about, what's the best mechanism for transporting the catalog to the consumers?
Yeah, and conversely, on the other end, it's something else that I mentioned as an open question is what type of metadata needs to be introduced to the plain v0 bundles to provide constraints to resolution. Like, for example, if we think about this input API or whatever kind of API we can use to interact with the pivoter component. Right now in plain v0 bundles, there's no concept of like this bundle is necessarily associated with a particular package or channel or anything like that. So that information conceptually needs to be, I guess, encoded in the plain v0 bundle when it's in the catalog source. So it's worth thinking about. We started looking at the metadata format and the new.
So I think we have that already, right? Like we don't have it in the plain bundle spec itself, but what we do have is a file-based catalog that you can group a bunch of bundles together and say, these bundles are in this package. So from the perspective of a component that's looking at the catalog source, it knows which package goes with every bundle. I think the beauty of having something in the bundle metadata itself is that it's easier than to generate the FBC effectively. But I think as like a very first pass, we could probably just say, if you want a bundle to be a member of a package, then here's how you create a file-based catalog in a hand jam, basically an OLM.bundle blob that says image is this and properties.package is this. And then we can read it and know what to do with it. Because at the end of the day, like on cluster, and this is how OLM works today too, I'm pretty sure. At the end of the day on cluster, like the source of truth for package information is the catalog, not the bundle metadata embedded inside the bundle image.
Right. No, that's fair. And yeah, we do have it available in the catalog. Right. And so the bundle and the bundle instance API themselves don't really have any concept of a package. They're just more.
And I don't, at least it's interesting because like in this context where we're talking about individual bundle images, maybe it makes sense for you to say like, oh, this bundle is in this package and have that metadata there. But in the context of like a resolve set bundle where it's kind of a composite bundle, what would the package be for that, right? Like maybe we could make up some name for it, but I think RecPack is a little bit generic and like doesn't necessarily always have the concept. Like a RecPack bundle might not have a concept of a package.
Right. Yeah, and I think this resolve set bundle idea is definitely one that's worth considering further. I guess as we think about this component and potentially its design, So I guess other follow-up questions, where should the pivoter live? As we start thinking about this component more and designing it more, does it make sense to maybe have its own repository and start looking at it? And also the potential combination of the pivoter and DEPI. Maybe someone who's more familiar with DEPI can speak to what state it's in currently and whether it makes sense to try to marry this concept of the pivoter that I presented today and DEPI, or whether DEPI is sort of more focused on the existing set of APIs. Can anyone speak to that? Yeah, so if not, then I think it makes sense just to treat DEPI separately, as a separate component, with its own goals. And this component that we kind of talked about today will be its own component. So I think the takeaways here are to basically further iterate on this design spec to include some of the comments brought up today, and come away with a better understanding of what we need for this component. Because we have good momentum on the RuckPack side of things, and it's worth starting to think about sort of some of the other components involved in the V2 world.
Dan, I feel like DEPI and kind of the description here are kind of serving the same purpose. And you even call out like, maybe we need a simple input API. But it makes me wonder whether, just like in RuckPack, how we have implementations of provisioners, it makes me wonder whether DEPI also has like a concept of a thing that knows how to resolve an input or a series of inputs. And I guess the hard part is like, what we're doing in DEPI is trying to look at all of the inputs and come up with one answer. So how does that work if you've got multiple implementations of things that are, let's say you've got 10 inputs that say, this should be resolved by pivoter, and another 10 inputs that say this should be resolved by DEPI. Like, does that end up, first of all, do we think we want something like that? And if we do, then what does that mean? Does that mean we like create two different resolve set bundles and then hope that they don't collide? So I think there's some interesting questions there. But in my mind, like what this sounds like to me is like the very first implementation of the simplest possible DEPI that could exist.
Yeah, that's totally fair. I think so, because I think DEPI is just fairly nebulous in terms of what we're trying to achieve. It also may be somewhat coupled to the existing registry V1 bundle and sort of the existing OLM APIs. I think it's useful to think about it outside of that context.
Yeah, like, so like, maybe to change topics a little bit, but like, I think this conversation is also our opportunity to think about, what do we think our upgrade edges should look like? Should we still have skips replace the skip range? Should we allow multiple upgrade paths from a single bundle? How do we pick the best one? Like there's all sorts of questions that I think we can open up now that we're talking about new APIs and new bundle formats. So maybe we should capture those as well and figure out if or when we want to start opening that can of worms as well.
Yeah, that definitely adds quite a bit of complexity if we wanted to go down that route. But I guess
kind of simplify maybe is to say like, okay, there will just be one upgrade edge type. And right now, like we can look at an existing catalog source and basically maybe we only use replaces, we only look at replaces or something, right? Like there's ways that we could simplify and then later say like, okay, well now you can actually like, we'll change our catalog spec to allow you to specify multiple replaces. And then that's how we, iterate and introduce it. I don't know. I mean, I think what you've got here is like basically what we want to do to like put a line in the sand and start iterating. So I think that's, regardless of all of these other open questions, I think we need to do something along these lines. And then we can start banging on it just like we've done with RuckPack.
Yeah, could you maybe speak to a bit about, you said you wrote the kube resolver and I looked at it a little bit. Does that overlap at all with this, or it's tailored to existing OLM bundles?
It could, right? Like we could take a look at that and tweak it a little bit to have it spit out something that could be converted into a bundle and bundle instance. But to give folks who aren't aware of that an idea of what it is. So last maybe August or September, we were talking about like all the complexity that operator authors have with how skip and replaces and skip range work, and especially in the context of like the imperative workflows around building catalogs, it's really, really difficult to make sense of what an upgrade graph is going to look like after you've been iteratively adding bundles to it over time. Like it's almost impossible unless you go and unless you know how it was created and can look at it yourself and rebuild it. So because of that, I started experimenting and came up with this idea of, let's just completely remove the idea of all these different upgrade edge types. Let's let you have an arbitrary directed acyclic graph that defines your upgrade edges. And let's also like remove channel as like a hierarchical concept within upgrade graphs. So rather than like channels defining upgrade graphs, it's an upgrade graph has nodes in it, and the nodes can say which channels they're part of. And then in the upgrade graph, you can have just any directed graph that you want. So which means that you could upgrade from V1 to both V2 and V3. And then you'd have to have something on the cluster that knows how to pick one of those after you've done resolution. So the idea, like to change from how OLM works today, is basically we do all the normal resolution that we do today in terms of like figuring out whether a candidate or whether something that's next in line is even a candidate based on dependencies and cluster state and whether there are conflicts or not. And we come up with a list of here's all the different candidates. And then what changes is like in current OLM, the set of candidates is like always ordered and you always pick the best one in advance. And there's no way to kind of customize how that choice is made. And this Kuber resolver idea that I had, that's like a separate API and like a separate way to answer that question. So the resolver would just say, here's a list of candidates. All of these are possible upgrades from your current installed operator. Let's delegate the decision of which one of those to pick to some other component. And then we'd have a default one that would just say like, well, just pick the one with highest SIMVer or whatever. But if you didn't like that decision, you could always pick something else. And then that kind of clears the way for us having basically multiple replaces. So anyway, like if we wanted to, Dan, I think we could pick that up off the shelf and tweak it a little bit to kind of be a proof of concept. But like the implementation was just enough to show the concept of multiple replaces, and it didn't make use of file-based catalogs or catalog sources or anything like that. So there would definitely be some changes to make. And then the other problem is that like, I guess you could say like skips is just another upgrade edge, but it has slightly different semantics in terms of how the resolver goes and eliminates things, but maybe that's not a big deal. Anyway, that's kind of the high level TLDR. If anyone wants to pick my brain about that more, feel free offline.
Yeah, I was just gonna say that I've been listening to the conversation, Joe. I was just gonna ask if you've got all this written down anywhere, because it feels like so the reason the skip range, all of that is introduced, they were also introduced iteratively, and the reason that was introduced, there was a need to introduce all of that. As far as I'm aware, I think that it started off with the simple replaces, but then it's got more complex. The catalog building process and then the need for skip and skip range were introduced. So I think Camellia, for example, had Camellia and Lance, they have some documents in the doc site that clarifies the naming conventions or how do you build upgrade edges. So there's been effort to kind of clarify all of that stuff, which means there are enough users of these concepts already. So just to make sure that we are taking into account those users who are already used to or whose use cases have already been taken care of, that I think it'll be useful to get all of those folks also in the conversation. So it'd be interesting to see all of these written down and be discussed, even if it is through an issue in the repo or something like that.
Yeah, I think that's totally fair. So I just I did a demo of this inside Red Hat. So I don't know if people can see that link, but if they can, then I think maybe it was Kevin that recorded it. So if you can't see it, then ask Kevin and maybe he can open it up more. But that video that I just linked is kind of an overview of what that whole Kuber resolver thing that I explained was. And Anik, to your point, like, I think it's possible that we could re-implement skips replaces skip range in a way that like still supports like multiple replace. Like all this really is saying is, rather than having the limitation of one replace, like let's allow bundles to say they replace multiple other things. Or really it's the other way around, right? It's allow a bundle to be replaced by multiple things.
I see. Okay. If there's the demo and there's more of a write-up, I guess I need to clarify my understanding of this. But yeah, that makes sense, I think, initially. But yeah, I'll take a look at that demo.
Cool. Okay.
Sorry. The one other thing, again, I think, like I said, I still have to look at the demo and everything that is being evangelized. But the one thought also that's coming up in my head is there was one time when we moved to the bundle format, and that was also a huge effort in converting over existing operator authors into the bundle format. And I think in today's world, I think there is way more operators than we had then. And even then, that effort was humongous. So I think it'll be probably useful to kind of keep that effort that will come after we change any of the formats also in mind, instead of re-implementing a lot of the concepts that we already have in these new APIs. Just another thought to keep in mind while we are designing these, I guess, if that makes sense.
Yeah,
No,
no,
I
that's
think that
fair.
totally makes sense. We definitely can't just scrap all the old stuff. We have to make sure that anything that anyone has done before has space to buy into Ruckpack. So whether that's offline migrations of all of the things, which I think is probably problematic, probably more likely what we want to do is have something that knows how to look at a registry v1 bundle and like use that inside of Ruckpack. So that's definitely something that's on the roadmap. And then what that also might mean, and Dan, this is maybe another use case for what I was saying earlier, where we might want different like implementations, or like a different way to, like, I guess the abstraction, right? Like we could have a pivoter that knows about registry v1 gRPC stuff and knows how to create a resolve set bundle from that. We could also have a pivoter that, we come up with this new index format and we want people to start buying into that. Maybe we have a different pivoter that implements that. The hard part, of course, is always like if we need to resolve down to just a single resolve set bundle, how do you get those things to coordinate? But maybe there's an answer for that too, where like there's yet another thing that knows how to merge or resolve multiple resolve set bundles into one. So anyway, there's lots of interesting things to talk about in terms of supporting all the old content and potentially migrating to new content and running those things together at the same time.
Yeah. No, there's definitely a lot of super interesting nuances here. I think ideally with a new packaging format, it would be one that people find more pleasant to use as well. As a goal, I mean, it's like with the file-based catalogs, like that was a huge UX improvement. So hopefully with the new bundle formats, that the new API support, things like supporting Git repositories, etc. Like hopefully the migration would go, could potentially go well because the formats are a little bit more friendlier and intuitive. But yeah, there's still a lot to be done on that front. Cool. I think we got through pretty much everything in the doc that I had for today. Does anyone else have any other questions or comments? I know it was a lot of information. Okay, sounds good. In that case, we can end the meeting a little bit early today. I'll give everyone 10 minutes back. So thank you for coming to the OLM Working Group today. Hope you enjoyed it. We have issue triage next week, and enjoy the rest of your day.